Before you blink, the universe expands. Not tomorrow, not in a billion years, right now. As you're watching this, galaxies are drifting away from each other at thousands of kilometers per second. Space itself is stretching, and if we rewind that expansion backward, far enough, everything, every star, every galaxy, every atom in your body was once compressed into something smaller than a single atom. No space, no time, no direction, just everything. This is the story of the Big Bang, explained simply, but in a way you'll never forget. Let's remove the biggest misconception first. The Big Bang was not an explosion in empty space. There was no empty space. There was no outside. There was no background. There wasn't even time ticking in the corner. When we say before the Big Bang, we're already making a mistake, because time itself may have started at that moment. It's not that something exploded into space, it's that space itself began to exist. Imagine asking, what's north of the North Pole? That question doesn't work. In the same way, asking, what happened before time existed, might not work either. Now let's go to the very beginning. About 13.8 billion years ago, the observable universe was compressed into a state of extreme density and temperature. We don't fully understand that exact first instant. Our physics breaks there. But we know what happened immediately after. Expansion, not normal expansion. A mind-breaking, faster-than-light expansion called cosmic inflation. In less than a trillionth of a second, the universe expanded from something unimaginably tiny to something macroscopic. Why? We don't know for sure. But without inflation, the universe wouldn't look the way it does today. Inflation smoothed everything out, like stretching a wrinkled sheet tight, and then the universe kept expanding. At the beginning, the universe wasn't made of atoms. It was too hot. Temperatures were so extreme that protons couldn't hold on to electrons. Atoms couldn't form. Even light couldn't travel freely. It was a glowing plasma, a chaotic ocean of particles and energy colliding constantly. If you were there, which you absolutely couldn't be, you wouldn't see stars or galaxies. You'd see blinding radiation everywhere. The universe was opaque, like being inside a star. Then something changed. After about 380,000 years, the universe cooled enough for electrons to combine with protons. Atoms formed, and when atoms formed, light was finally free. That ancient light still exists today. We detect it as the cosmic microwave background. It's not a theory, it's measurable. It's literally the afterglow of the early universe. When scientists first detected it in 1965, it was one of the strongest confirmations that the Big Bang actually happened. You can think of it as the universe's baby picture. Once atoms formed, gravity began shaping the cosmos. Tiny fluctuations in density, almost nothing, became important. Slightly denser regions pulled in more matter. More matter meant stronger gravity. Stronger gravity pulled in even more matter. Over millions of years, clouds of hydrogen collapsed into the first stars. Those stars were enormous, violent, short-lived. Inside them, nuclear fusion forged heavier elements: carbon, oxygen, iron. When they exploded as supernovae, they scattered those elements across space. Every atom heavier than hydrogen and helium, including the ones in your bones, was forged inside a star. You are not just in the universe. You are made from its earliest chaos. Stars gathered into clusters. Clusters merged into galaxies. Galaxies formed massive structures. Cosmic webs stretching across billions of light years. If you zoom out far enough, the universe looks like a neural network. Filaments of galaxies connected by gravity. Huge voids in between. The structure we see today emerged from tiny fluctuations in the early universe. Differences smaller than 0.01%. Small variations became everything. Here's the part that makes this real. The Big Bang isn't over. The universe is still expanding. In 1929, astronomer Edwin Hubble discovered that distant galaxies are moving away from us. The farther they are, the faster they recede. This wasn't random motion, it was expansion. Imagine raisins in rising dough. As the dough expands, every raisin moves away from every other raisin. No raisin is the center. In the same way, there is no center of the universe. Expansion happens everywhere. Here's the twist. In the late 1990s, scientists discovered that expansion isn't slowing down. It's accelerating. Something called dark energy is pushing space apart faster over time. We don't know what dark energy actually is. We only know it makes up about 68% of the universe. So most of the universe, we don't fully understand it. And that's not poetic. That's real. Now we reach the biggest question. What started it? And here's the honest answer. We don't know. Some theories suggest quantum fluctuations, multiverse collisions, cyclical universes, something beyond our current physics. But right now, the cause of the Big Bang remains one of the deepest mysteries in science. And that's okay. Science isn't about pretending to know everything. It's about pushing the boundary forward. Think about this carefully. Every galaxy you see in a deep space images, every black hole, every supernova, every planet, all of it began from one expanding state, not scattered pieces coming together, but one continuous expansion outward. If you rewind the universe like a movie, everything converges. Galaxies merge, stars collapse into plasma, atoms break apart. Energy condenses until everything becomes one. And then, physics stops making sense. That boundary is where our understanding ends. When people hear Big Bang, they imagine destruction. But it wasn't destruction. It was possibility. It was the moment when matter could exist, light could travel, gravity could shape, complexity could form. Life could eventually emerge. Without that expansion, there would be no time, no chemistry, no consciousness, no one asking questions. The Big Bang is not a giant explosion in space. It is the beginning of space expanding. Everything we see today is the result of that expansion cooling down and organizing itself over billions of years. Simple in idea, unimaginable in scale. Right now, somewhere in deep space, galaxies are forming, stars are exploding, planets are assembling, and all of it traces back to that first moment 13.8 billion years ago. The universe didn't appear inside something. It expanded into existence. And you, made of ancient star material, are the universe's way of observing itself, from a singular beginning to conscious thought. That might be the most extraordinary expansion of all. If this video made you see the night sky differently, hit like. If you want to explore the next cosmic mystery, subscribe. And comment what topic we dive into next. The end of the universe? Black holes? Multiverse? Until then, keep looking up.